type. Which measure of central tendency is least affected by extreme values? We have the median extreme value. So what am I trying to say? If we have something 1, 2, 3, 4, 50. Example. What is the median? The median is 3. If I change this 50 to 100, what is the median? 50. If I change this to 2, what is the median? It is 3. So you see mode and you see mean, they are affected by extreme values. Okay? They can be affected by extreme values. The mode is defined as the most frequently occurring value. Okay, these questions are very cheap questions, right? Very cheap questions. Now, in a perfect symmetrical distribution, when confined in space, these questions can be paraphrased, and it will be a disaster if you go to the exam and see a question that was paraphrased that you are watching in this video and you feel it will be a serious disaster. So take note of the questions, understand the question very well. So no matter how they are paraphrased, you are saying question and answer. You can get better than you see answer and question, which means that they can use the answer and ask it as a question. Then the answer will now be the question. Do you understand? So now, in a perfectly symmetrical distribution, pick the answer. You might get it right, they'll tell you, pick it, they'll put the answer there and they'll tell you what is this. So you'll be the one to say, oh, this is perfectly symmetrical. Alright? So let's move on. In a perfectly symmetrical distribution, the mean is equal to the median and the mode. So I'm happy you can just set this question. They'll give you a guitar. You know, say find the mean, find the median, and find the mode. And once you calculate and you see that these three things are having the same value, it does make it perfectly symmetrical. The distribution is perfectly symmetrical. It's as simple as that. 54. Which measure of central tendency is particularly appropriate for categorical data? You have your mode. 65. The geometrical mean is particularly suitable for exponential growth rate. The geometrical mean is undefined when any observation is 0. You know, right? 0. Once you have 0, the geometrical mean does spoil. Okay? Or you can't get it rather, it's undefined. The harmonic mean is particularly appropriate for finding average speed over equal distance. Now, please take note. You should know mean, arithmetic mean, harmonic mean, and what geometric mean. You should know the differences between the three. You see a question, you tell you find the geometric mean, find the harmonic mean, find the arithmetic mean. You should know how to solve it, okay? A weighted mean gives different observation. A weighted mean gives different observation, different importance according to their weight. When all weights are equal, the weighted mean becomes the arithmetic mean. Which measure is most suitable when extreme observations are present in a database? Use the median. Remember, it's median that is not affected. You use mean, your values will change as they alter. Now, correlation. Now, correlation and regression is one aspect of mathematics where mathematics department is to shine, because it has a lot of intrinsic calculation that people don't even pay attention to, but trust me, they are very, very simple. Once you understand the basics, you are good to go. Right, so correlation, what does correlation measure? Correlation measures the direction and strength of the linear relationship between two values. Okay, so you're just checking how they correlate the direction and the strength of a linear relationship. The correlation coefficient is commonly denoted as R. Anywhere you see R, for example, it's not like what? Correlation coefficient. The value of the correlation coefficient is like between -1 and +1. That is why if you take any answer, you say 2. If it just means that you are solving nonsense or you are out of case. So your answer must fall to me with -1 or what? +1. As simple as that. The correlation coefficient of +1 indicates perfect positive linear correlation. So you can give you a question, it will tell you to solve it. It will not ask you what is it? Is it perfect positive linear correlation or perfect negative or no correlation or weak correlation? Or these things you must know them. Right? The correlation coefficient of -1 indicates perfect negative linear correlation. Alright? The correlation coefficient of 0 indicates no linear correlation. A positive correlation means that both variables tend to increase together. Yeah. Then a negative, both what? Decrease. So one variable tends to increase and the other decrease. That is when you say it's negative. So when there is one decrease, it is automatically a negative correlation. Correlation alone does not establish causation. Causation is ignored. Regression analysis is primarily used to predict or estimate values of one variable from another. Regression to predict and estimate values. In regression analysis, the variable being predicted is commonly called the dependent variable. What you are predicting is known as what? The dependent variable. Then the variable used to predict the dependent variable is what is known as the independent variable. And it's very common. Sometimes you see, I tell you what is the dependent variable, what is the independent variable in calculations. Okay. The regression equation of y on x is used to estimate y from x. That is just what it means. y on x, y from x on y, x from y, or just change it to from. Okay. The regression equation of x on y is used to estimate x from y. The regression line of y and x passes through the point x and y. The regression coefficients are commonly represented by, so you see it as byx and bxy. Okay. The relationship between the correlation coefficient and regression coefficient is, this is the relationship here. What is the square root? The answer addressing that. Please take note, it's not what is the square root, because you can go there that day and see how the options are square roots, okay? But square roots, take note of that. The correlation coefficients and both regression coefficients always have the same sign. This is another thing you should take note of. They always have the same sign. If one regression coefficient is greater than 1, the other regression coefficient must generally be less than 1. Less than 1. If R is 0, the two regression lines are perpendicular. This one is something that you must know. They tell you, give you a question and your R is going to be 0. You now ask you what is it? Is it perpendicular? Is it parallel? You take note, it is perpendicular when it is 0. And when it is plus 1, it is coincide, right? Coincide when it is plus 1, plus or minus 1. Okay? So regression coefficients are invariant to a change in origin. Change in origin. Okay? Regression coefficients are affected by a change in scale, right? Change in scale. Then probability is a numerical measure of course, the certainty or likelihood of an event occurring. Right. It's right. The probability of an event must lie between 0 and 1. You cannot have minus 1 as probability. It's 0 and 1. Okay. See, the probability of the sample space is 1. Is 1. Okay. 1. An event with probability 0 is called impossible event. It means that the event cannot be possible. So it just means that if today is Tuesday and they ask you tomorrow is going to be Friday, probability 0. Take note of that. It says an event with probability 1 is that the event is certain, is correct. It's very, very correct. What is the probability now? 1 plus 1 is 2 base 10. It's 100%. So it's 1 because it's certain. The classical definition of probability is based on equally likely outcomes. Okay? According to the classical definition, probability is the ratio of the favorable cases to the totally equally likely cases. The classical definition of probability is limited when the number of outcomes is infinite or outcomes are not equally likely. The empirical definition of probability is based on relative frequency. So you can see now, we have classical definition, we have empirical definition. I beg you take it off, please. Relative frequency probability is obtained by dividing the frequency of an event by the total frequency. I've said this question came out in one of the statistics questions we solved above. 94. The complement of event A is usually denoted as AC, right? You should remember that as complement of AC. The probability of the complement of A is 1 minus P probability of A. Your complement is more like what is not part. Okay, so 1 minus that probability of A, that's how you get the complement of A. For any two events A and B, the general addition rule is option B. So you have probability of A union B is equal to probability of A plus probability of B minus probability of A intersect B. I take note of that. It's something that you shouldn't forget. Except if two events are mutually exclusive, then that means two of them cannot be without themselves. Mutually exclusive. You have the A intersect B to be 0. Okay. For mutually exclusive event, the additional law is option B. All these things are things that you take note of. They are so important. All these calculations, all these symbols that you are seeing that looks like Chinese, take note of them. Don't mix them up, I beg you, because you must definitely come across them one way or the other. For independent events A and B, the multiplication law is, if you know addition law, if you know multiplication law, all these laws, please take note of them. Two events are independent when the occurrence of one event does not affect the probability of the other. Okay, that's what we say independent. Which of the following measures of central tendency is most appropriate for a distribution containing extreme observations median? You can see, but see that question again. Which of the following statements about the parameter is correct? It describes the population characteristics. Of course, it is not sample. Sample parameter is for population. Okay. not sample. Which of the following is a major limitation of the classical definition of probability? It requires equally likely outcomes. Which of the following best distinguishes the descriptive statistics from the inferential statistics? Descriptive statistics summarizes data, while inferential statistics does what? Draws conclusions. As simple as that. If the correlation coefficient between two variables is minus 0.85, the relationship is what? Strong negative. Please take note. Strong negative. Strong negative. Which of the following statements about correlation is correct? Correlation measures the strength and direction. We have said this earlier. Correlation measures the strength and direction of the linear relationships. Okay. If R is equal to 0, the regression line is what? Perpendicular. It's coming again. Don't forget. Which of the following is true about regression coefficients? Okay, they are independent of origin, but dependent on what? The scale. Which of the following condition identifies independent events? Option E. I think I should have a material where all these things are written. So you just study them, look at them, study them very well. These guys here and all the laws. Okay, just study everything. If two events cannot occur simultaneously, they are said to be mutually exclusive. So one must occur first before the other one. Both of them cannot, they are not independent at the same time. They cannot occur at the same time. Which of the following is true for mutually exclusive events A? I've done this before, just paraphrasing of the question. Which of the following statements about geometrical mean is correct? Geometrical mean is particularly useful for growth rates. Okay, growth rates. The harmonic mean is particularly useful in situations involving average speed over equal distance. We've asked this question before. Which of the following is not a component of Stoichio? Correlation. This one is very simple. Correlation coefficient does not coincide Stoichio. So there's no connection. The regression equation is primarily used to estimate the value of one variable from another.